Now we already saw a particular method of causing synchronization between multiple threads so that it's, multiple threads are not working on the same common entity in a way that we get an inconsistent result. So we use the keyword synchronized, but really that provides us with basic synchronization, but then it is very rigid in its use. So for example, if we have a particular thread and that can be only locked once using the synchronized keyword. Synchronized blocks actually don't offer any mechanism of a particular waiting queue, and then after one thread exists that particular block or method, then any other thread can take the lock. So that probably can cause starvation of resources for some other threads which is waiting for a very long period of time. So starvation is actually a thing in which a thread keeps waiting for a particular resource, but just because other threads are able to get that particular synchronized resource before it, it actually keeps waiting and is, almost starving for the particular resource. One good way of avoiding this is known as reentrant locks. And the study of reentrant locks is extremely important for us to understand that, we may have things which we might be locking, and then it may be happening that, your program comes at a particular stage in which you have all the resources being locked, and some threads are waiting for other resources. They have some resources locked currently and they are actually waiting for other resources to be unlocked. And they keep doing that until there is no way the system, the program can come out of that situation, and that is known as deadlock. And to understand what is deadlock and how it happens, we really need to understand about reentrant locks and how we could use it while working with multiple threads. So to demonstrate that, I'm actually going to create a new class for you, and I would just call it lock demo. Now in this, I'm actually going to create a shared resource. So for example, we have this static int count. This is something, which we really want to probably increment or decrement in, different threads. And this is the common, resource which we are going to work on. So now I'll create a main method over here. And in this, I'm actually going to create a new thread. So I'll just call it thread1, and I'm just going to create it using the new thread and just passing a new runnable as usual, the way we would do. And within this new runnable, I'm going to override the run method. So we have public void run. And in this, basically what I want to do is, let's say for I equal to 0 to 10, what I want to do is just, increment my counter. So what I would do is simply do count plus plus. And now I want to actually do, the same thing in another thread as well. So I would have a thread 2. And this would do, essentially the same thing. And this starts from a capital. But it doesn't have to start from a capital. It's supposed to be small. Okay, so we do have thread 1 and thread 2, and what we can do now is actually start both the threads. So what I'll do is thread 1 dot start, and similarly I would do a thread 2 dot start. Now let's actually try to also print what's the value of count after, both these things. So I would say count is. And now let's try to run this. What do you think would be the output? So we have count is equal to 10. Let's try to run this again. Count is equal to 0. Let's run this again. Count is 10. So now we have some sort of inconsistency happening over here. Now the reason is that this is a main thread which is actually printing count, We also have thread 1 accessing count and thread 2 accessing count. What thread 1 is doing, what thread 2 is doing at the same time in which I'm actually wanting to print it, we do not know. So that's why we have an inconsistency. Let me actually, wait for these two threads to, complete. So probably in my main thread, I will just sleep for some time, let's say half a second, and then see, what's going to be the count after that. So let me try to run this again. Now we have count equal to 20. And we keep consistently getting count equal to 20 just because we waited for both the threads to actually complete working. So now we have both these threads working. Like in between, if I try to print the count, I do not know till where the thread 1 has gone. I do not know till where the thread 2 has gone. What I can do is I can actually also add a sysout over here. So I would write count is count, and same thing I would do in the other thread as well. And now when I try to run this, so you see that count is, keeping increasing, but, we do have, the printing happening in a pretty haphazard manner. So this is how I have, two threads, each working on the same thing, incrementing it 10 times each, and then at the end, I do have my count incremented completely by both the threads. Now, I do not want this haphazard manner thing to happen. I want to actually have a lock working, in each of these loops, in each of these threads. So I want to actually create a new lock, and that is known as the ReentrantLock. And that is a static lock which I would have in this particular class, in which I'm actually, working with different threads. So this lock is actually coming from the lock class, and I would just call it lock. And this is going to be new ReentrantLock. Now let's do the required imports. So I have this particular lock. If I want to actually, lock this particular, for loop, then I actually have to have something known, something like synchronized, which we saw earlier. So within my run, first I will get the lock. So I would do lock.lock, and then once I have completed this particular statement, then I would, do an unlock over here. So I would do lock.unlock. So what this essentially is doing is that, as soon as the thread 1 starts running, it would gain the lock. First, it will complete this particular thing, then release the lock. And this lock is actually a static lock value of this lock demo, right? So any thread which is, working within the lock demo is actually going to work as per this particular lock. So obviously we need to actually lock the other thread value as well, right? So I would do the same thing, lock.lock and lock.unlock after my for loop completes. Now let me actually try to run this now. Now you can see I do have this proper, my first for loop is working properly, and my second for loop is also working after that properly, and I have finally my count equal to 20 properly in the main method. So this is how I would have, my lock working. In this particular scenario, what we want is that we want to lock the thing, the lines of code which is working on our shared resource, and then unlock it. Now make sure that, every time we actually lock something, we are able to unlock it. But because, otherwise, let's say, something happens, in the for loop, some error happens and this statement is never reached. So that means the lock would never be able to be unlocked, and I would never be able to work with the same lock in any other thread. And we do not want that, right? So instead of, just writing unlock over here, we should actually write it within a finally. So what I'll do is, after I gain the lock, I would start a try block. And once my try block is completed, then I would have my finally block. And as you know, finally block is something which definitely is going to work, whether there is any error in the try block or there is no error in the try block. This is definitely going to work. So I would put this try block again, after acquiring the lock, I would write everything in my try so that, any problem which happens, at least my finally block definitely is able to, work, and my lock is definitely being unlocked. So when I try to run this now, we have this exact same output. We have no inconsistencies, and we have used the reentrant lock properly. We also have made sure that, the lock would always be unlocked, whether or not my try statements cause any issue or no.